Okay, so in this particular lesson, we're looking at doing sort of two different sets of skills, solving a system of nonlinear equations and a system of inequalities. So this is not a matrix lesson per se, but does involve some of the system of equation stuff that we looked at the start of the unit. One of the things that I find helpful is if students understand the types of images they're looking at. Now this is a topic that we don't teach exclusively in college algebra. But again, I think it's a little bit easier to understand why we have so many answers if we understand what on earth we are looking at. So I just wanted to briefly talk about some of the general forms. And again, we don't necessarily need to know how to manipulate it, but it does kind of help to know how to recognize it. So for example, linear equations look like ax plus by equals c. So there's some x, some y, and lines look like lines. Nothing shocking there. We actually are really good at lines because we've seen a lot of them. Circles have some number squared plus the same number squared, y squared, I'm sorry, x squared and a y squared, and equals some sort of constant. And again, the idea being that there's a plus in between and that it's the same number for both. And of course, a circle is, it's round. Parabolas have a squared, one of the variables is squared, so it could be on the x or it could be on the y, and they look sort of like a U shape. And again, that's not something we address in detail in college algebra. Do a little bit with parabolas as far as transformation goes. We have something called an ellipse, which is when the constants are different in front of a and in front of x squared and y squared, but again they're adding and both terms are squared. And ellipses are sort of elongated football type things. It kind of looks like someone smushed a circle. And hyperbolas are when there's a minus in between them. And hyperbolas look like that, or there's two sets of parabolas. Again, so it's not necessary that you understand how to generate the shapes, but I wanted you to see that if there's a squared term there, that squared term actually does mean something, and it's not just thrown at you with no understanding about what it does to the actual image. Okay, now as far as solving a nonlinear system, again, one thing I like to do is ask what are the possibilities for this. So we're looking at a line and a parabola. So if you draw a line, you could have where they don't touch at all. You could have a situation where there's one point of intersection, and we could have a situation where there's more than one intersection. Okay, so as we're solving this, sort of keep that in mind, that we're looking for that number of answers. And because we don't understand how to graph these things, then we can't really tell graphically how to do that, but I can use substitution elimination. So I'm looking at my variables here, and I like that 2x plus y equals -6. I think that one's pretty easy to isolate out the y. I think I can get rid of that pretty quick. So I'm going to go with substitution. So I'm going to take that equation, and I'm going to rewrite rewrite y in terms of the other variables. So I'm going to bring the 2x over. So y then equals -2x minus 6. Okay, so then from here, I'm going to take that statement and replace it into the x squared plus 2y. So that's going to look like x squared plus 2 times, that's that -2x minus 6 equals 0. Okay, so then I'm going to distribute, and let's just kind of solve and see what we end up with. So I get x squared, looks like minus 4x, and minus 12 equals 0. Okay, well, that's a quadratic, And we're good at those at this point, so we want to try to factor that. Let's see, so that's got to be x and x, and 12 I can break up as 1 and see. It's 1 and 12, 2 and 6, 3 and 4 would be the only choices there. And I know it's got to be a negative somewhere in there. And the only combination that I can visualize a 4 coming out of is the 2 and 6. So I'm going to make 1 be 6 and 1 be 2. And I need the bigger one to be negative, which means that one's positive. Okay, so then I'm going to solve for x. And I should get positive 6 and negative 2. Okay, now at this point, let's kind of go back to what the possibilities were and kind of think, well, what have we just shown? If I've got two x values, that means it must cross this parabola twice. So I am looking at this third case here, which is all fine and dandy, but I just need to solve for y at this point. So I've got one y related to the 6, and I got another y related to the negative 2. So I'm going to go back to that equation I wrote. So y equals negative 2x minus 6, and just evaluate that. So negative 2 times 6 minus 6, and y equals negative 2 times negative 2 minus 6. And that'll give me my two numbers. So I get, let's see, negative 18 for the first one. And here I get to what, 4 minus 6, so negative 2. Okay, so the very last thing is to partner up the correct ordered pairs. So I have an ordered pair at 6 comma negative 18, and I've got an ordered pair at negative 2 comma negative 2. And so that's my solution to that particular system. Okay, so in this example, first thing I would like to ask is, what are we dealing with here? I see they're both squared terms, and I see they both match on the x squared plus y squared equals 8. So that means I'm dealing with some sort of circle. And then I see I got one squared term, so I got a parabola. Okay, so I see a situation where the parabola and the circle don't cross. I see one where maybe the parabola is upside down, so it crosses once. We could have it so maybe the parabola is off to the side, so it only crosses twice. Let's see, we could have it do 3 times, once there and twice there, or it could be below it and it touches 4 times. Okay, so that's our list of possibilities, anywhere from 0 to 4. And again, we don't need to know the graph to do that. We're just going to solve, to do the math. So in this particular system, I like elimination. So I'm going to multiply that bottom equation by negative 1. And so that would give me, let me copy down the first one. So give me that, and then down below I'd have negative x squared minus 2y equals 0. Okay, and when I combine like terms, the x squareds cancel out. The y squared and the 2y, those aren't like terms, even though they're on top of each other, so I can't, those aren't going to go away. But I do get y squared minus 2y equals 8. Okay, so now I have enough information I can solve. So we're going to bring the 8 over. So y squared minus 2y minus 8 equals 0. Then we're going to factor that. So let's see, it's got to be y and 4 and 2. I need the 4 to be negative and the 2 to be positive in the factored. And solving for y, then I get negative 2 and a positive 4. Okay, so I have two y values, which eliminates a couple of my pictures there. So now I need to go back and find x, and I see, Let's see, I like this x squared plus 2y because that seems pretty easy to work with. So I'm going to bring that down. X squared plus 2y equals 0. I'm just going to solve for y real quick. So that's x squared equals negative 2y. All right, so let's evaluate that. So I got x squared. Let's see, so we got two y's we're going to find. We got y is negative 2 and y is 4. Let's see what happens. So x squared equals negative 2 times negative 2. So we get x squared equals 4. Okay, on board there. And let's take the square root. Remember, we take the square root, we get plus or minus. So we get x is plus or minus 2. Okay, so let's go to the other side with the 4. So x squared equals negative 2 times 4. So x squared is negative 8. Okay, now when I take the square root, I get x is, now we're taking a square root of a negative. So that's, there's an I in there. Okay, so at that point, I'm going to give up on that one. So that means even though it works for 4, there's no x value where that matches. So the only place I actually get ordered pairs is from the negative 2. So my solution set, I have one with a positive 2 and a negative 2. And I have one with a negative 2 and a negative 2. And then the 4 doesn't give me anything. So there's only two ordered pairs that work in that particular equation. All right, so in this example, just want to start by thinking, well, what are we looking at? That first equation, being that it's just x and y without any exponents, means we're looking at some type of line. And then the second one, you've got squared things, means you've got a circle. So they could, well, as it was drawn, they couldn't even cross at all. Let's see, think of a scenario where they cross once. So somewhere where maybe the circle's on it, or maybe the circle goes through it, in which case it would intersect twice. Okay, and that's about it. So as I'm solving this, I expect it to be either once, twice, or none, one of those. And let's see, I don't see a way for us to eliminate anything, so I don't see that we could maybe multiply the top by something to get it to cancel out with something on the bottom. But I do see a way that I can get rid of one of my variables by doing substitution. So I am going to do that. I'm going to take this 2x plus y equals negative 6, and I'm just going to bring the 2x over. So that's y equals negative 2x minus 6. And when I do that, then I'm going to substitute. So go into my equation here, x squared plus y squared equals 1. And that's where I'll get the negative 2x minus 6 that I will square. And if you remember, that squared means we're doing two of them side by side. So I'm just going to FOIL that. So x squared, let's see, negative 2x times negative 2x is 4x squared. And negative 2x times negative 6 is 12x. And then down there we get negative 6 times negative 2 is also 12x plus 12x. And then negative 6 times negative 6 is positive 36. Of course, equals 1. And let's see, like terms, I see x squared and a 4x squared, so I get 5x squared. Oops, I dropped an x there. Plus 24x plus 36 equals 1. And then I will bring over the 1. So that's 5x squared plus 24x plus 35. all of which equals 0. Okay, so at that point, now we're looking at factoring. So let's see, there's only one way to get 5x squared. That's just 5x and x. 35. Let's see, well, 5 and 7. Except, well, let's see, let's make a list. Yeah, 35 and 1, and 5 and 7. Okay, so as we're playing with these numbers, I mean, I can put 5 and 7 in here, so I'm going to put the 5 here and the 7 here. Now, as I try to FOIL it, just to double check that that's the right factoring pattern, I notice a slight problem. So I notice that, let's see, you know, multiply across there, I get 25 and 7. There's just no way. So this thing is not factorable. Now, that doesn't mean all hope is lost. That just means we can't factor it. So we're going to have to tie into some other knowledge that we are aware of to figure out what x is. And we're aware of the Pythagorean theorem. So we're going to do that. I'm sorry, we're aware of the quadratic formula. I meant quadratic formula. So I need A, which is 5, B, which is 24, and C, which is 35. And then, in which case, I get x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. Now I'm looking at our numbers and I already see what the problem is. And actually, let's just jump right into this piece right there. If I do 24 squared minus 4 times 5 times 35. Sorry, notice I dropped a parenthesis there. Okay, 24 squared minus 4 times 5 times 35. I get negative 124. So we are dealing with the square root of negative 124, which means we are dealing with some form of I, some number with I in it. Okay, now let's put this in context. I asked algebraically, I asked where do these two equations match, where do they meet? They don't. Okay, we'll go back up to our scenarios. One of those situations had them not even touching each other, had them not even crossing, and that was this first one right here where, you know, the line was just away from the circle. So there is no particular solution to this system. And that's the only way that you would know that is when you go to solve, you find that there's no line in common.